Hello friends, in this AV we are going to solve a few numericals of the chapter Work, Energy and Power of ICSE class 10. We are going to talk about exercise 2B. So before we talk about the exercise questions, let's take a look at the formula that we are going to use to solve the numericals of this exercise. Here we will be using the formula for gravitational potential energy, which is represented as U as mg and h. This is the same formula that we use for potential energy as well. Then we have the equation for kinetic energy, that is half mv square. Then we have the relation between momentum and the kinetic energy k. So momentum is equal to root over twice m multiplied by k, or if we write this equation in terms of k, then k is equal to p square by twice m. Here the p stands for momentum. And finally we have the work energy theorem, that is work done is equal to final kinetic energy minus initial kinetic energy. Now let's look at the very first question given here. Two bodies of equal masses are placed at heights h and 2h. We have to find the ratio of their gravitational potential energies. Now we know the formula for gravitational potential energy, that is U is equal to mgh. Now both the bodies have the same masses, that is m, and height is h and 2h. So we just put it in the formula, and here we assume that let the two bodies of masses m be placed at height h and 2h. Now the ratio of the gravitational potential energy mg and height of the first body, that is h, divided by mg and height of this second body, which is 2h. So we see that mg and mg will cancel out, h and h will cancel out, we are left with 1 by 2. So the answer is 1:2. Now the second question says we have to find the gravitational potential energy. Here you just need to multiply the numbers given to you, that is U is equal to m, it's given to you, that is 1 kg. G is given to you and height is given to you. Just multiply and you'll get the answer. So we'll take a look at the third question. The third question says a box of weight 150 kgf has the gravitational potential energy stored in it equal to 14,700 joules. We have to find the height of the box above the ground, and we have to take acceleration due to gravity g as 9.8 Newton per kg. Now here we have been provided with the gravitational potential energy. So U is equal to 14,700 joules. Weight is given to us as 150 kgf, and force of gravity we calculate because they have given us the weight, that is m into g. So m is taken as 150 multiplied by 9.8. So this comes to 1470 Newton. Now we know the formula for gravitational potential energy, U is equal to mgh. From here we have the value of U, we have the value of mg, we can calculate the value of h. So we just place the value, 14,700 is equal to 1470 multiplied by h. So you take this number to the other side, so h will be 14,700 divided by 1470, that is equal to 10 meters. So this is the solution for this. Now let's take the next question, and please note that this is a very important question. It says that a body of mass 5 kg falls from a height of 10 meter to 4 meter. Now we have to calculate the loss in potential energy of the body and the total energy possessed by the body at any instant. And they have given us the value of small g to be equal to 10 meter per second square. Now here we have written the given things. it is given that the mass of the body is 5 kg. Now we have to calculate the loss in potential energy. So we will calculate the potential energy at individual heights, that is at 10 meters and at 4 meters, and then we'll subtract it. So potential energy at height 10 meter is equal to mgh. So we put the values 5 into 10 into 10 because mass is 5 kg. Value of small g is 10 meter per second square and height is 10 meters. So we get 500 joules. Now potential energy at a height 4 meter is again mgh. So mass is 5 kg. Acceleration due to gravity is 10 meter per second square and the height is 4 meters. So this comes to 200 joules. So the loss in potential energy is equal to 500 minus 200, that is 300 joules. The second part of the question asks us to calculate the total energy possessed. Now here please know that for free fall the total energy remains constant at every point, but as you all know that at the topmost point the body stops for a moment before it starts coming down. When you throw anything up, it will reach the maximum height, it will stop there for a fraction of seconds and then it will start coming back to us. So at that point, at the topmost point, the kinetic energy is 0 because there is no speed, and the total energy is the sum of kinetic energy plus potential energy. So highest point is this one at 10 meters. So for that we have calculated the potential energy to be 500 and kinetic energy is 0. So the total energy is the potential energy only, and that is 500 joules. Now for question number 5, please use the formula U is equal to mgh, and using that formula you can find the value of h. Now question number 6 says a boy weighing 25 kgf climbs up the first floor at a height of 3 meter above the ground to the third floor at a height 9 meter above the ground. What will be the increase in his gravitational potential energy? Now this is again a very easy question. I have full faith that you all will be able to do it. We just have to use the formula that the gravitational potential energy is mgh. So instead of h we will be writing h2 minus h1. So you can just have a look here. Question number 6, it says, so the force of gravity on the boy, that is we are calculating m into g, that is 25 multiplied by 10, so 250 Newton. Now increase in the gravitational potential energy is, the formula for gravitational potential energy is mgh. Here we have two heights, so we write it as mg h2 minus h1. So 250, h2 is 9 meters and h1 is 3 meters. So 9 minus 3 is 6. So 250 into 6 is 1500 joules. Now if you look at the next question, that is question number 7, they have asked us to find the gravitational potential energy. Again, I'm not going into this question, just use the formula U is equal to mgh and you will get the answer. Now the next question, that is question number 8, we will try to solve it. Question number 8 and question number 9 are important, so let's have a look at it. Question number 8 says a man of mass 50 kg climbs up a ladder of height 10 meters. We have to calculate the work done by the man and the increase in his potential energy, and the value of acceleration due to gravity is 9.8 meter per second square. So here we have written the given things, that is the mass of the man is 50 kg, height of the ladder is 10 meters, and we have to calculate first the work done by the man and then the increase in potential energy. So work done will be mgh, we have the mass that is 50 kg, we have the height as 10 meters, and the value of acceleration due to gravity is 9.8. So please multiply it. and you will get 4,900 joules. Now the second part of the question says we have to find the increase in the potential energy. So here they are rising from ground to a height of 10 meter. The height of the ladder is 10 meter. So ground becomes our reference point. I have written here, you may see that ground is the reference point, which is our height h1, because whenever we are finding the increase in potential energy, then we have to use the formula mg h2 minus h1. So h1 is the initial height, which is the ground. So here h1 is 0 meters, that is there is no height, it is at the ground level, and it reaches a height where it uses the ladder, so it reaches a height h2, that is 10 meters. So gravitational potential energy or increase in the potential energy will be mg h2 minus h1. So mass is 50, small g is 9.8, h2 is 10 meters and h1 is 0. So again we get the answer as 4,900 joules. Now question number 9 says a block A weighing 100 Newton is pulled up a slope of length 5 meter by means of a constant force which is equal to 100 Newton, which is given in the figure here. Now what is the work done by the force F in moving the block A 5 meter along the slope, 5 meters along the slope, and what is the increase in the potential energy of block A, and finally we have to account for the difference in the work done by the force and increase in the potential energy. Now that the loss of energy will appear as the heat because it is going against the force of friction. So that third part is also given here in the book. So we will just try to solve the first and the second part. Now, so here weight of the block is 100 Newton. Force applied is 100 Newton again. Now the first part, that is work done by the force, is equal to, we know the formula work done is equal to force into displacement from the first chapter. So force is given as 100 Newton multiplied by displacement. It's already given in the question, that is 5 meters. So 100 into 5, 500 joules. Now what we have is the second part of the question. It says we have to find the increase in potential energy. So that is equal to, again U is equal to mgh. Now here mass remains the same, acceleration due to gravity remains the same, height becomes 3 meter, because if you look at the figure, when this block covers the distance of 5 meter, it reaches to this point, which is 3 meters from the ground. So height becomes 3 meters, and we have here height is equal to 3 meters. So now we just put mg 100 multiplied by 3, that is 300 joules. Now for question number 10, they have asked us to find the kinetic energy. Please use the formula kinetic energy is equal to half mv square. You don't have to convert anything, they are given in the SI unit, so you'll get the answer. Number 11 and 12 also is the same, don't have to do much of effort. Now question number 13 is a little important. Let's have a look at it. It says that two bodies of equal masses are moving with uniform velocities v and twice of v. We have to find the ratio of their kinetic energies. Actually, I have a feeling that you will be able to do this question as well, but since I've solved, let's have a look at it. See, here for number 13, it's given that both the bodies m1 and m2 have the same mass, that is m. Now velocity of the first body is v1, that is v, and the velocity of second body is twice of v. So if we take the ratio of kinetic energy, k1 by k2 will be equal to half m, velocity of the first body is v, so v square, divided by kinetic energy of the second body, that is half m, because mass is the same for both the bodies, but the velocity is 2v, so 2v square. Now half m cancels out, v square is v square, 2v square is 4v square, so v square will get cancelled out, and we are left with 1 by 4. So the ratio of their kinetic energy is 1:4. Now question number 14 will be done in a similar manner, so I'm not going into that. Please check question number 16, which is important. Now here it says a cannonball of mass 500 gram is fired with a speed of 15 meter per second. We have to find its kinetic energy and its momentum. Now second part of the question, that is the momentum. It's very simple. You have done the formula for momentum in class 9, that is momentum is equal to mass into velocity. Let's have a look at the first part of the question. Now here it says we have written the mass of the cannonball, that is 500 gram, but we know that the SI unit of mass is kg, so we convert it into kg by dividing it with 1000. So when we divide it by 1000, we get 500 grams is equal to 0.5 kgs. Now the speed v is equal to 15 meter per second, that is given in the question. The first part of the question says we have to calculate the kinetic energy. So kinetic energy is equal to half mv square. So half mass is 0.5 multiplied by velocity square, that is 15 square. So you can check the calculation after putting the values, and you get the answer as 56.25 joules. The second part of the question is we have to calculate the momentum. So momentum is denoted as P. P is equal to mass multiplied by velocity, that is mass is 0.5 multiplied by velocity is 15. You get the answer as 7.5 kg meter per second. Another important question that I want to discuss with you is question number 18. It says a truck weighing 1000 kgf changes its speed from 36 km per hour to 72 km per hour in 2 minutes. We have to calculate the work done by the engine and its power. Now here why this question becomes important is they have given the speed in kilometer per hour, but we know that the SI unit is meter per second, so both the speeds will have to convert in meter per second. Now here you see I have written the initial velocity u is 36 km per hour. We convert it into meter per second. So kilometer to meter we multiply by 1000 divided by r. So r to second, 60 into 60, that is 3600. After calculation we get it as 10 meter per second. Similarly for final velocity v is equal to 72 km per hour. We multiply it with 1000 divided by 3600, we get it as 20 meter per second. Now they are in the SI unit. Now mass of the truck is given as 1000 kg. So work done is equal to half m v square, but here we have two velocities, so final velocity square minus initial velocity square. Now we put the values, half mass is 1000, final velocity is 20, so 20 square minus the initial velocity which is 10, so 10 square. 20 square is 400, 10 square is 100. So half into 1000 is 500, 400 minus 100 is 300, and you multiply it. Now we write it in standard form. So instead of 15 multiplied by 10 raised to the power 4, we put a point and we write 1.5 multiplied by 10 raised to the power 5 joules. The second part of the question where we have to find the power is, we know the formula power is equal to work done per unit time. You have done it in the previous exercise. So we just put the value of work done which we have calculated here divided by the time taken, that is 120, because they have told us in the question that it takes 2 minutes. So 2 minutes converted into second is 120. So after division you'll get this as the answer, 1.25 into 10 raised to the power 3 watt. Now the last important question that I want you to practice is question number 22. It says A bullet of mass 50 grams is moving with a velocity of 500 meter per second. It penetrates 10 centimeter into a still target and comes to rest. We have to calculate the kinetic energy. This is very easy part. You can calculate it very easily. The second one is we have to calculate the average retarding force offered by the target. So here I have solved. The mass of the bullet is 50 grams. That is divided by 1000, converted into kg. So it becomes 0.05 kg. Velocity is 500 meter per second. So the distance that it penetrates is 10 centimeter. We know that SI unit of distance is meter. So centimeter to meter, when we have to convert, we divide it by 1000. So we get 0.1 meters. Now kinetic energy of the bullet is half mv square. Half, mass is 0.05, velocity is 500. So square it, calculate, you get the answer. Now resistance or resistive force that we have to calculate, we have to use this formula. Work done by the bullet is equal to resistive force multiplied by distance. So we have the work done, which we have calculated here, and we have the distance. So we just put the value and we calculate the resistive force is equal to 6250 divided by 0.1. So we get the answer as 62500 Newton. I hope this AV is useful to you. Thank you. Happy learning. God bless.